So again, we're going to be focusing on Unit 3 today, and what's interesting about Unit 3 and is the fact that there's a lot of focus on data and then structures. Now, from the first unit, one of the things I try to emphasize is programming, as it were, generally, is about data coming in and data going out, right? And then you have some kind of engine in between, an algorithm, a program or something, right, that does something to that data and gives you some kind of output. And part of your mission here is to be able to build that engine. But to be able to build that engine, to be able to accept data and get data out, you need to be able to understand how to organize that data, put that data in a form and shape where the computer will be able to ingest that data. Now, when I say that, I'm not talking about data in its absolute sense. I'm more talking about the kind of containers that will carry the data, right? When you begin to talk about data cleaning, data arranging, and all of that, that's something completely different. And that would be more like what people would do, would people that will want to use the algorithms or the systems that you built. That's the kind of thing they want to do, right? Prepare the data and then run it through the system. But in your case, you're literally actually trying to build the structures that will contain those all of that data. So one way to look at this is assume I want to move house, right? If I'm moving house right now, one of the things, chances are that I would need to move some china, breakable cups and all of that, right? I need specific kind of containers to put it in. I need to move some frozen food, right? I need specific kind of containers to put all of that in. And then eventually I might have to put that all of that in a box, in U-Haul, right? These are all various kinds of containers to be able to transport um, all of the data, more like all of my property. I need to be able to do all of that to be able to do that. So to effectively do the transfer of my stuff from house A to house B, I need to be able to make sure I have all the right containers to be able to put in all the data that I need. So again, our focus today would be looking at additional data types and structures, understanding them, understanding what they do, and every other thing around that. So we are literally building on what we have done. Again, in the beginning, we talked about different data types, right? Talked about character, strings, integers, boolean, double, on and on and on. So I'm going to go back, and some of the things I'm going to talk about today are actually the things I already mentioned the last time, but I'm going to focus today going in depth. And then hopefully in the future, we can pay more focus on maybe the exercises or other things arising. So I'm going to share my screen right now. I'm going to share my screen and just everybody, uh, just a minute. Let me share my screen. Windows, and let's go with this. Just a minute. Do we go with screen? Okay. So I would assume you can see me now. Um, just a minute. That's my screen. Let me get one of this. So I'm sharing my screen. And just a minute. Let me reduce this. Okay, so that's my screen right here. Oops, this is probably not what I need to. Just give me a moment, a moment, a moment. Okay. A moment, please. Let me stop sharing the screen. Okay, I think you can see my screen right now. I think I wanna operate from this screen. Sorry about the delay. I want to make sure I'm running from a screen where you can see my cursor. So this is exactly where I am right now, and our explorations again. This is where we are. IoT exploration. So I want to make sure you see where we are on the map. This is us here. Organizing data. Building apps is where we're actually going to focus on a lot of the apps and utilizing all of the knowledge we've gathered around this. So if you haven't been doing the exercises, I highly implore you to please go work on some of those exercises, because you will need the bulk of knowledge you've taken from unit 1, 2, and 3 to help begin to actually build the apps now. So organizing data it is, like I mentioned to us, and you're going to I'll hopefully send these slides, but these are a couple of things that Unit 3, the kind of knowledge we want to acquire, which is things you want to be able to develop skills for organizing and processing data, learn more about the types. And types, the word types is a very programs, Swift program generic type of word. You know, a lot of the data you're going to encounter would be of a certain type, and they are generally called types. And as we go down, I'm going to show you the different kinds of types. Now, types have properties and they have methods, right? So every type has methods and properties. And we're going to talk some more about that. We're also going to learn how to create custom types with structs, learn how to order data in arrays, and how to process arrays using loops. Those are, it might sound kind of foreign if you're not very familiar with programming, but we're going to get to all of that. So at the end of the day, there's a couple of things we should be able to do with all of the knowledge we've amassed from all of that area. And uh, some of those would be, just a minute. Yeah. So some of those would include, a minute, let me close this. Share my screen again, just a minute. Yeah, some of those will be creating an old school pixel art and some animations, extending the data visualizer. There's a data visualizer we built earlier, and then creating an algorithm to determine password security, and the bouncy ball app, a prototype for uh, the app, an interactive prototype for your app in Keystone. Keystone is Apple's version of the PowerPoint, and usually there is a part it plays in helping you design, or what I would call the pre-design stages of your app. You need to be able to, one option is to use Keynote to do that, and those are part of the things we will touch down the line in the course, and then draft a user experience survey, which you would use later to test your prototype. And these are some of the things you need to do before you actually go into the actual app design. So getting started with organizing data, the last time I talked about this, I mentioned the fact that collections, so the word collections, right, they are used for storing collections of values. So think of them like boxes, right? Like the description gave you in the beginning, there are different kinds of boxes that you can use to do your moves, right? But the kind of box you use depends on the properties of what you want to store in them, right? If you're trying to store fragile materials, you want to put them in certain kinds of boxes. If it's some really like an engine block that's really very heavy, you want to look for something that is more robust to be able to store. So generally in programming or in Swift, they are generally called collections, and they are used for storing collections of values. So I can store 6 different glasses, right? Or tumblers for drinking water, drinking wine, or drinking whatever, and I want to store them. So collections. Now, so a collection is a sequence whose elements, right, Usually, the word collections suggests that it's a sequence, a couple of different elements, right, put together. So, but this, how you define a collection is it's a sequence, and I'm going to show us the example whose elements. So typically, a collection has several elements, right, and sometimes they are ordered, and I'm going to talk about that a little bit, or they are unordered, and you're going to find out what it means to be ordered or unordered, right? So it's a sequence of elements that can be transversed, meaning you can actually go through them. So for example, if I have a table, right, and I want to multiply everything in the table by 2, it's possible for me to go 2 times each element of that table, right? So in other words, I can automate an operation to go through every element within that table. And for a collection, right, I can do that, and I can do it in a non-destructive manner. And each of those elements, the way they are designed, they are in little cubicles, right, where I can actually find I can use numbers to locate their physical, to identify their physical locations. And I'm going to show you what that means as we this is an example of what I mean. So if I have, say, think of these as houses, right, on a street, right? Ben lives here, Mary lives here, Hilda, Philip, Johnson, and Sarah, right? Each of them live in each apartment along the street. Now, the way programming works, which is literally the way the decimal number works, right? We usually start counting from 1, but it's actually 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you reset the counter and start from 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and you reset. And now when you look at those numbers vertically, you see everything, all the zeros line up and all the ones line up, all the twos line up, because that's how decimal works. So the addressing system of data, right, in programming is generally organized in that way. So if I ask, so these are that's the location addresses for each of these elements, and these are called elements, right? Their location address will start from 0. So it wouldn't be house number 1, house number 2, house number 3, house number 4, but it's going to be house number 0, 1, 2, 3, 4, 5, 6. So when I think of item number 3, right, in our colloquial everyday description of numbers, I'm going to say this is house number 3. But the way the computer reads it, it reads it as 0, 1, 2. So this is, for us, this is house number 3, but for the computer, it is -1, right? Because it starts counting as 0. So this is an example of a collection. And we're going to talk about the different kinds of collection. And the 3 primary types of collection are your arrays, your sets, and your dictionaries. And I'm going to describe what exactly those are, but this is a generic example of a collection. So when you look at this, right, where the name of this collection is names. Let's assume it's names, because I'm trying to store a bunch of names inside a square, uh, uh, a square bracket, right? So I say let names, and we all know what let is, right? It's a constant. In other words, we can't change either of this. Equals to Ben, and because it's a string, that's why you have the quotation marks around it. Ben, Mary, Hilda, blah, blah, blah. So if I decide to print this, right, and you can try that. And in fact, if it's possible for you, just open up your playground. If we run some of the codes, I probably might find a way of copying and pasting some of the code. You can run and try it, right? Or even if you don't do that, just pay attention. You're going to get these slides and you can try all of this later. So if I say let names equals to blah, 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 all of this, right? If I run this in Playground right now and I say print names 0, right? It's going to print out Ben. That will be the output. And I say print names 4. I'll start 0, 1, 2, 3, 4. So that's how I get Johnson, right? So collections, that's essentially how collections behave. And that's which takes me back to what I talked about. So a collection is a sequence whose elements can be transversed, right? Multiple times. So you can go through all of those elements non-destructively, and they can be accessed by an indexed subscript. So each of those numbers, right, are like they are indexed subscripts or the address. Just think of them as addresses. So that whenever I'm looking for Philip, all I just need to tell the computer is I'm looking for Johnson. I don't need to know Johnson's name. I just tell the computer, hey, 4, right? And it would quickly pick up 4 for me and show me Johnson. So per collections, there are 3 main collection types, right? We have the arrays, the sets, and dictionaries. And these are different ways of organizing my data so that the computer would understand that data. So depending on what kind of situation it is, I might have to store. There are things I can store, for example, in an array that I can't store in a set because they are too fragile, or they're just not the right kind of data to store in that kind of data structure. So essentially 3 main types of collections: arrays, sets, and dictionaries. Now, look at this. Sometimes people talk of an extra type of array that's called tuples. Now, we don't categorize tuples to be part of the 3 main collection types because tuples are kind of different, and I'm going to show us why they are different eventually. But ahead of any further description, it's important to understand that tuples are more like compound. Okay, think of them like, so I have my 3 boxes, right? One of the boxes have my fruits. The second box, have my glassware, because I don't want to store my glassware here because my things might break. So I decide to store it here. And then these stores something very, very heavy. Like I couldn't commingle them with this, right? Now, eventually I go get my U-Haul, right? The hatch behind the U-Haul is a box in itself, right? It's just a bigger box. Now I pick each of this. I can actually pick this, and all load them behind my U-Haul and on my way. So this is more like a compound type of data structure that can be used to load up any number of other data types and data structures, right? And just carry them. So that's why I said it's used to group together multiple values of different types into a single compound value, and you're going to see examples of that as we proceed. So the other thing to discuss before I start talking about these different collection types and their behavior and what kind of data you can store in them is to talk about what we refer to as ordered and unordered values. So just a moment. So that's part of what I'm going to talk about in that area. Let me see if I can use this other computer. But before, okay, seems like yep. I hope you can still see my screen. So I'll go. So I'm talking about ordered collections and unordered collections. So we talk about, like I mentioned, there are 3 main types of collections: the array, the tuple, the sets, and the dictionaries. Tuples, for example, like I mentioned, are actually compound collections. But then look at them, only arrays are ordered. And what exactly do I mean by ordered arrays? Look at this. Now, the difference between ordered and unordered arrays, what I discuss here actually what I discuss here are characteristics of unordered items, right? unordered items or elements or whatever you want to call them. So for one, notice I've written this var, which is variable, right? And then I have the student array. And this is how you create an array. You simply type the word, you include a colon, type an array, and I'm going to talk about array in a few minutes. But for purposes of this description, that's how you create an array in case you haven't created one before. So, and essentially with arrays, I'm storing all of these data types that are very similar to each other, right? So I'm storing 12, 11, 1, 12, 1, 14, 1, 16, 1, 18, 1, 15. I got that. Then I have, this is a different data type. So I'm actually looking at two different data types here, the array and the set. Now, notice that I feed them the same numbers, same number of elements, 1, 2, 3, 4, 5, in a certain order. 1, 2, 3, 4, 5. And then I ask to print out student ID array and print out student ID sets, right? If I print both of these, look at the output I'm going to get. And again, try this out yourself, right? If I print this out, this is exactly what I'm going to get. I'm going to get something like this. 112, 112, 114, 114, 116, 116, 118, 118, 115, 115, right? So in this case, their address location is fixed. That's what it means to be ordered. Another way to look at it is, let's say you come into an office, right? You have your desk at one corner, open floor office, right? You have a desk at one corner of the office. Every single day you come into that office, you're still going to sit on that one desk, right? Nobody changes your address or your location. That's an ordered collection, and that's what arrays are generally. But for sets aren't that way. Sets are something like the first person that comes to the office decides on what desk to sit. So if you come on 10 different days, you could have people sitting on 10 different locations, right? Depending on the mood of the day, right? Or where the first set of people decide to show up. So if you look at this, right, even though it starts with 112, 114, 116, it's now 115, 116, right? If you run this code again, all of a sudden it might start with 118. That's a case of an unordered collection, which literally means I have a certain number of seats, but nobody is entitled to any seats. I can randomly shuffle you guys all around when I wish and how I wish. So that's why it says, talks of the characteristics of unordered items. They do not have a defined order, right? They can appear in a different order every time they are used, or anytime you run the code, they would appear in a different order and cannot be referred to by index or key. In other words, just like I was able to call the last array here, I call, if I call this by 0 and then I get Ben all the time. Ordinarily, if I'm dealing with a set, right, or I'm dealing with a dictionary, or I'm dealing with a tuple, there's no guarantee that if I enter 0, I'm still going to get Ben. Any questions though? If anyone has questions, you can just unmute yourself and ask. So, any questions? I don't think there are questions. Please, if you do have one, let me check the chat if anyone has something going on. Okay, nothing. So to my point again, arrays are ordered, right? They are an ordered collection of values. Tuples are unordered. They don't have, like, you can't locate a particular element at any one address at any one time. It's very random. The computer automatically assigns all of that. But as you begin to spend more time coding, and the implications might become a little more apparent. Nothing I want to go into right now, but it's important to have an idea of what's going on. So I'm starting with arrays to tell us a little bit about arrays. So a couple of things about arrays, characteristics. They are ordered collection of values. We already have seen that, and I just showed us a typical example. You know, it's a collection of the same types of elements. So if I'm using strings, they are going to be a bunch of string elements. If I'm using characters, they have to be a bunch. I can't mix and match the data types. That's just how the array is designed. You can't mix and match the data types. Whatever element you're using has to be the same element. Reason, because I don't want my glasswares to be packed with some of the metals I have from my garage, right? Because somehow I think those piece of metals are going to crack. So if I'm going to pack everything in metal form, I'm going to put metals there. If I'm going to put glassware, I'm just going to pack glassware there. So that's how arrays behave. The same value can appear in an array multiple times at different locations, different positions. What exactly does that mean? What this means is I have these elements 1, 2, 3, 4, 5, 6, right? I can have 100 repeat 4 or 5 times here, right? So if I come to a class and I have 30 students, and 4 of the 30 students, now assume that this is student grades, right, that I've entered here. If I have 4 or 5 students that have 100 in their results, and that's their score, I can store all of that in the array. Does not discriminate. It can't complain and say something like, why do we have 2 or 3 different people having 100 here, right? Arrays don't do that. The only thing about arrays is you want to put the exact same data type. That's one. Number two, those data types are ordered. You can't change their location. Once they are assigned a location, the locations cannot be changed randomly, except maybe you add a new element or you remove an element, right? That's the only time their location can be altered. So how do you create arrays? I think I've pretty much mentioned that. We're assuming that you want to create the record of 6 students, right? And they've scored different things, on their exams. Instead of creating 5 different variables where I say var Peter equals to this, right? John equals to this, Andrew equals to this. I don't want to do that, right? Let's say I just want to store all of this data together, right? I could literally come here, and that's where, instead of creating just one variable and assigning it a value, I use an array to store all of them together, right? So this is for like 6 students, 1, 2, 3, 4, 5, 6. These are their grades, right? And I've done that. How do I do that? Usually I start with deciding whether it's a variable or a constant. Then I give it a name, and then a colon, and then I include array, and then I type this. Sometimes you don't have to include arrays, right? And those are cases where it's implied. But for now, let's just go with, you want to just type array, then equals to, because you're initializing or telling the system immediately, hey, I'm trying to create an array, and then equals to, and then you have your array. Now, the next thing you want to do is surround the elements with square brackets, and then after each element, you introduce a comma. And that's you there, you have created an array. And then you can call that array. Now, like I mentioned, right, you can't mix and match the data types that you store in an array. This is an example of different kinds of array. Remember this backslash that I have here? These are essentially comments. So the computer doesn't run them. It's just comments to be able to tell you what's happening in the next line. So I say let's even numbers. Notice I didn't include my array here, but the system just does understand that I'm trying to set up an array, right? So, and I say something like this, right? And these are integer elements, because all of them are integers. and then we have string elements because all of them are strings, right? If I bring in 2 and introduce 2 here right now, it's going to give me an error because arrays do not accept multiple data types because the integer is completely different from the string and they can't cohabit in an array. This is double elements, right? That's why we are also having to store double elements. So if I included something like 200, right? I'm not going to get an error because the system would typically read 200 to mean 200.00. So I think this is what I mentioned before. This the addresses of each of these elements, and this is very important, and that's what we literally call the index. Now, the other thing to mention about arrays is arrays have what we call methods. Remember, I know I had mentioned this whole thing, right? All the data types, almost all data types, right? You can literally consider them as objects, just like, say, humans, dogs, and all of that, right? Or cars, or any noun, right, has two things going for them. They have attributes, which is what we call properties, and then we have methods, which is something that has to do with their behavior, how they behave, right? The kind of actions that is peculiar to um, objects or objects in that particular class. That's the same way we have these data types, right? Or data structures like array. So array has properties and it also has methods. And there are so many methods. And these methods are literally functions, right? Or little programs that have been written, right? And those programs have a name. Remember when we talked about the function, right? And then the function has a name. And then you can call that function. That's what's happening here. So there are so many methods. Those methods, those functions, right, are literally called methods. Now, for me to extract some kind of behavior from my arrays, right, to extract some kind of behavior from my arrays, I could automate them, right, by building some kind of intelligence into them. And that intelligence is so for example, some methods for a dog will be barking. A dog barks, right? That's a method. That's what gives the dog intelligence. That's why it's not a piece of wood. It's alive and it has specific characteristics. So same thing with arrays, right? So a dog can bark. A dog can jump. A dog can howl. All of those are the methods of the dog. Same thing with array. When the programmers, right, building Swift created arrays, just like God created dogs, right? God imbued in dogs certain characteristics. Same thing when the programmers created arrays or that particular class of collections, they imbued them with certain abilities, wrote codes for those abilities, and now I can call each of those um, attributes, or rather methods, right? And then they would begin to manifest. That's literally what's going on here. So I'm trying to break it down to the lowest common denominator because I'm not sure the knowledge level of every single person in the class. So if you already know this, please just be patient with us. So that's what's happening here. So there are several methods and I'm going to show you those methods, but I'm going to be talking about just one of those methods. Then I would show you several other methods, and then I would encourage you to go try out those methods, right? Go Google them, look at them, create the methods or apply the methods, create your own arrays and apply the methods to those arrays and see what kind of results they give you, because there are different abilities and behavior of arrays. So one of those is called array, and the keyword for is called insert. And the keyword for insert is insert and then open and close brackets, right? Round brackets. That's the name of this method, right? So what's the syntax for calling for using insert. It will be whatever your array is. Remember, we already talked about our array. So this, for example, is my array, right? This is my array. That's my array name, even numbers, right? So if I'm going to use insert in even numbers, I'm just going to say even numbers dot insert. And I like you to see what insert does now. Array dot insert, then I open and close my bracket, and then this is, assume this is the new element I want to insert, because all it does is actually add elements to an array. In other words, I have these elements 2, 4, 6, 8, 10, 12, 14, 16. What if I want to add 18, right? How do I do it? All I need to do is use that element, right? Insert to insert. So that's the new element I want to. So if I'm going to write out a line of code to insert a said new element, and in this case, my new element is 18, I want to include art, right? And then I will tell it the index where I want to insert it in. So let's go back up here, right? So this is 0, 1, 2, right? If I want to insert it here between 6 and 8, I'm going to say 0, 1, 2, 3. So what I would type here will be 3. I will say 18, comma, at colon 3. And immediately it would insert it there. So let's look at a specific example. So I'm looking at this. These are my bunch of even numbers. I've created these even numbers 2, 4, 6, 8. And I remembered, oh my God, I'm supposed to have included 10 here because like the next even number is supposed to be 10, but I've already created this and I don't want to start afresh. How do I insert 10 here? All I just need to do is type out my my array, which is my array. That's my array dot insert. Then 10 is the number I want to put there, and I'll be like at 4, right? So in other words, I want to put it at location 4. If I want to count that, that will be 0, 1, 2, 3, 4. That would be 10 will be between 8 and 12, right? And that's why we get this as an output. If I ask it to print this, it gives me back this. Any questions? So because of time, we are not going to bedevil ourselves to go through all kinds of, and there are so many methods that have been created for arrays. And these are just the different abilities of an array. Think different things an array can do, right? They've been writing, why is it more efficient to use the insert method than to just go to the array and type it? Oh, no, so it doesn't necessarily mean that it's more efficient. Sometimes this has something else to do with when you are probably writing a code. Let's say you've written something, you've written 1,000 lines of code, right? And you know, you have all these kind of things that have already gone in there. You want to, so for example, if I had something like this, right? A piece of code of a few lines, it's very easy to just go there, go put that. But there are certain operations where you might begin to write your code, and there are many other things that have already happened where you can't just go and start changing things like that. All you need to do is just include it at some point. That might not be a perfect illustration, but there are actually specific cases where you find out it's actually more efficient. So the example I gave is overly simplistic for what it is, and I can understand why you would ask that question, because like, why can't I actually just go there? That would actually be the smartest things to do. But then there are particular situations where that will not be the efficient thing to do, even though it's not, I'm not pulling anything directly off my head right now. So these are examples of some methods, right? You know, if you want to append, if you want to join, if you're looking for the minimum, if you want to remove a particular, so these are all of them. So my point is, if you want to understand any of the any of the methods, just go type in append, open and close brackets, and just say syntax for append blah 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 in Swift. You're just going to see it, and then you immediately you know what to do, and then that's how you begin to use them. So like I mentioned, programming is just like regular natural human language. Something you haven't encountered, vocabulary that you haven't encountered, you can't use. So the more you expose yourself to more and more vocabulary, then you find yourself having more vocabulary in your arsenal. And then when you need to use it, you can always have recourse. So same thing with this. So these are the bunch of arrays that I kind of found for a bunch of methods that I found for arrays. So if I want to sort, right, maybe I want to sort it in decreasing order. Remember, it has fixed index locations, right? I can decide I want to arrange it in ascending order or in descending order. And remember, we are, just like the question, that was asked the last time, right? By Laura. So for example, if I'm trying to sort something, maybe in my array, I have 1,000 different integers, right? So one way to do it, for example, if I'm trying to sort, would be to go pick every one of them and graduate them in an increasing order, but a quicker way to do it. So if I had only just 5 elements in my array, I could literally just go change it. But if I have like 1,000 different elements in that array, then using sort would be a smarter thing to do, because if I try to go arrange those things, one, I can make mistakes, and then number two is going to like take forever. So that would be an example, for sort. So same way for insert, there are particular conditions where that just happens to be the best thing to do. So the next collection type is set. Now, set is very similar to arrays, right? They behave almost the same way, except for maybe 2 things, right? At least 2 things that come off my head right now. So one of those things so they are very similar in that they are a collection of unique data. In other words, you can't be mixing different types of data into sets. But the second thing is that sets cannot be duplicated. Remember how I said in arrays, right? I can have 4 students that made 100 in their grade, and I can still put all of those elements in an array. But in a set, I can't do that. If you put 4 of those students, their grades, it's just going to eliminate 3 of the grades and keep 1, right? So specifically used to do specific things, right? That's where you use sets, where you don't want a duplication of numbers, right? You just use sets. So even if you have 20,000 different entries and you want to, for example, do a count to know how many unique numbers there are, right? What you want to use is set. Maybe something like, I don't know if he has a method for count, which I think he should have. So it'll be something like set.count, and immediately it will give you the number, irrespective, even if it is 20,000 elements that you fed in there, but let's say only 10,000 of them are unique, is going to eventually give you, that the count, the number of unique elements is 10,000, even though you have 20,000. So that's part of the kind of thing. So this is an example that I use here. I'm assuming this is an array, and I have 112, 112. Notice it's repeated, and these are the only 2 repeated elements. And there are how many elements? 1, 2, 3, 4, 5, 6. So if I run this, right, and I print out my student ID array, it's going to still give me my 1, 2, 3, 4, 5, 6 in the same order, right? And my 112 shows up here, 112, 112 shows up. But if you run this here, see what you're seeing. One of the 112 has disappeared. You only have 112. And then notice the other thing, right? Because ordinarily, if it was an ordered pair, all that would have happened is one of these will go, and then this will remain in this particular order. But look at how random it is. All of a sudden, it's shuffled things around. Now, if you run this code again, right, you might end up seeing that 116 is here and 118 is maybe somewhere here. So it's each time it goes through that operation, it shakes things around. And then the second thing it does is that if there are any duplicates, it will completely remove those duplicates. So suppose we want to store, say, the social security number of your employees or your clients, right? Then you need to do that with a set, right? Because if there are any duplications, the set would only pick one of those. But if you store that in an array, the array would publish. If that number appears 2 or 3 times, it will publish it over and over again. So I already mentioned that it's a collection of unique data, same type of data. That's the example I was talking about. Like if I want, so this probably would actually be let. I'll probably use let because these numbers are not going to change. But that's the point I was trying to make. If you duplicate any number here, it will just reject it. So like arrays, if I want to insert something, right? Look at what I do. That's my syntax. I just use new elements. Notice that what you call it, the index. Remember, let me go back so you can see this. Remember here the syntax, right? I'm going to tell it where to include my where to insert the new element because I'm giving it the specific address. I'm saying, hey, I have a new tenant that's coming in, right? His name is new element, but I want you to put him in apartment number 4, right? So like having a new employee that's coming, right? Hey, I have a new employee that's coming in, but then I don't give a specific address where I need him to sit. Just tell him anywhere when he shows up, any seat he sees, just take it. Because it doesn't make sense for me to give a specific address, index, or location because it's not ordered. So that's why you have this. So simple, if I want to say insert, so this is a typical example, right? I create this set, right? And I give the name colleges in South Carolina, the set, and I said USC, Clemson, South Carolina State. Yeah. And then I print the following are the colleges in South Carolina. And then I use my this. So all it does is it goes here, pulls all of this, right? And then it shows me this output. The following are the colleges in South Carolina. It gives me USC, South Carolina State, and Clemson. That's what it gives me. But if I want to insert Benedict College, I realize, oh my God, I forgot to include Benedict College. If I want to insert it, all I need to do is I just pick up my set dot insert and then I include the name I want to include here. I don't need to include the location because that's not relevant. It's just going to put it anywhere, right? And I say here is an updated college list, right? And then it just prints it. Benedict College, South Carolina State, USC, and Clemson. If I print this a second time, you might just change the order and go get Clemson first. But this is exactly, that's one of those methods. So if you come in here, right, there are several other methods that do all kinds of things. How do I want to become like very good at what I do? I might need to just go Google each of those methods and Google for examples of how they are used. Create write a couple of lines of code of my own and see the result that I give, and then that information is going to be with me forever. Each time I want to be able to solve a problem, then I'm thinking, okay, there's a method for set that can do blah blah blah. So those methods are just, if you remember, I think it was the last class or the class before that when we talked about APIs. Remember the dancing robot, right, that we did in the exercise. We never wrote a line of code. All we just did was bring a couple of functions, that work together, reorganize them, and they start doing all of this. So this is methods are a way of you not having to write a code, right? But pulling up standard codes that have been written by the creators of the program to be able to help you do specific things you want to do. So I haven't used union, for example. What I would assume union will be something like if I have two different what you might call it, two different sets, and I want to join them together, I will use something like join, right? To join them or something. I don't know. I haven't looked at it, but again, or I'm trying to check whether is a certain set or a certain set that I have is a subset of another set. I probably will be using something like something dot is subset. So it's asking, is this a subset of this, right? And if you're writing code, there are certain things you want to find out, and this is how you use them. Or I want to say, if this is this, then do this. So I have a particular set, and I'm saying, if you check if this is a subset of this. If it is, then do this, else do that, right? You see how these methods can be used? Same thing. So it's important to go through these methods when you have time, read through them, find out what they do, and proceed. So the next collection we're going to be talking about is the dictionary. So what exactly is the dictionary? Um, Again, it's the third collection, specific type of data type. And again, just I'm sure you're familiar with what I mean when I say it's there. Some collections are ordered and others are unordered. The dictionary is an ordered collection of elements or items. In other words, they don't have a specific index address. Anytime you run a code that contains dictionary, the elements can be changed in any order randomly by the system because it just wants to. It doesn't. You can especially get the results. So if 4 or 5 of you run you know a code, right, a line of code, or a piece of code, right, that has dictionary, you might get different results in terms of the positioning of the elements. Same elements, but arranged in different conditions. So the other thing is about dictionaries is remember what dictionaries like. I don't know whether that word was specifically picked from diction to be picked as an illustration, right? So a dictionary is literally a book, some kind of book, right, that gives you a word and its meaning. So I have a word, then I have a colon, and then it tells me the second part or the meaning of that word. That's how dictionaries are. And it's for storing data where I have a particular key and I'm looking for the value of that key. So for example, for when you're filling out a form, right? A lot of forms, say you go to the doctor's office, one of the things that you're going to be hit by is something like your name, first name. That first name is asking you for a value. So they are giving you the key, you're providing the value, right? First name, you give the first name. Surname, you give the surname. Address, you give the address. Age, you give the age. That's a dictionary. Very straightforward. That's how simple these things are. That's a dictionary. So if I want to store that kind of data, I probably want to use a dictionary. So that's what a dictionary is. So it stores elements, right, in pairs. You have a key and a value. So the keys are unique identifiers that are associated. There's an association between the key and the value. Just like if you have a word in the dictionary, there's an association between the word and the meaning it provides. So that's what essentially a dictionary is. And I'm going to show us an example, lines of code of a dictionary. Again, if you find the time, go play around with some dictionaries, get comfortable with them because if you are confronted with a specific problem, or maybe when we're actually building the app, you might run into a situation where, oh, I'm trying to create a form where I accept data from people. How am I going to do that? The first thing that should come to your mind is, oh, could it be dictionary? You know, so this is what I have. That's an example of a dictionary. Again, the unique thing about a dictionary is it always involves a key and values pair. So this is a dictionary with keys and values for favorite food for different persons. Say var, right? Favorite food equals to Samuel. Samuel likes rice. So I map Samuel colon rice. Susan likes spaghetti, right? So I map Susan to spaghetti. Karen likes pasta, and I map Karen to pasta. And then I print my favorite food, right? And this is what I get as my output, right? It stored that data. So at some point, I might be able to create some kind of input, where once Samuel pops up, Samuel can enter his rice as his favorite, Susan can, and then at the end of the day, I extract all of that data and convert it into JSON and maybe into Excel, for someone to now collect it. So clients, customers, or everyone that is coming through your door is entering all of that. You're using a data type of this sort. Now, notice that what you're doing here, an array can do it. And that's the idea of why you have different data types, right? You can't, use set to do this, right? Because if set sees two Samuels, right, that both like rice, all of a sudden is going to kick out one of them and just use one. So different data types, different behaviors. This is another example, right? Where in this particular case, notice that we use two data types, same data types, right? This is a string, right? Here we are trying to combine a string and an integer. String and an integer. You can also do that in dictionaries. They can actually combine those kind of um, accept two different data types. So that's what you have here. And this is a typical example. And if you run this, it's just going to show you. The only thing is it's not an ordered pair. Notice, instead of, I would have expected ideally that it will give me 1 colon Toyota, but it gives me Honda first because it's not an ordered collection. So if I run this again, it might give me Tesla first, right? So it has no respect of address. Everybody, whoever shows up first is the one that has the seat. So that's how you create a dictionary. So look at this, for example, like the example I was alluding to, right? You give someone, create an app where you're trying to take all of this information from people, right? You create the keys and you prompt using a line of code. Please include your first name, and then Kelvin types his first name and then last name, and it does age, blah blah blah, and it accepts all of that. So if I'm writing this, right, I'm going to write something for this particular. If I create a dictionary for something like this, it's going to be var. This is the name of my dictionary, personal info string. So this is something I was writing and I got an error, right? So remember, this wasn't included, right? And I think I don't want to go deeply into that. Notice that that wasn't included here, but I don't want to go deeply into that. I just wanted to just show us, right? I've put my name, first name, last name, age 36, height 36, weight. Now I'm combining all kinds of data types, right, in different kinds of combinations. One of the things when I ran this is the error it gave me, right? Heterogeneous collection literal. So all I did was I typed in this error into Google, and then I saw people that had had the same problem, and all they said, it started talking can be inferred. So it wants me to be specific about the string type that I'm using, and I think that's why they recommended this string any. So I haven't tested it, but what I suspect is it converted everything here into a string, including the integers. So obviously, if I want this to remain integers, I would have to figure out how to be able to write this. But those are things that you begin to do as you begin to practice your coding. You run into those errors. You go online. There are always people that have been through what you've been through, and then you interrogate, find out what they've done, and that's how you keep learning. So dictionary like set and arrays also have their own methods. One of the methods that I picked up is the enumerate method, right? What does the enumerate method do? It returns a sequence of key value pairs with their indexed values, right? So let me show you what it means. So this is the syntax. Dictionary dot, so whatever the name of your dictionary is, so like in this case, the name of the dictionary is personal info. I'll say personal info dot enumerate, and then it's almost like I'm creating a function. Let me just show you. So it's going to be something like this. So I create information, for example, this is the information about somebody, who was born in 1909 and died in 2020. Let's say I'm creating a dictionary for this, right? I'm taking in the birth date and taking in the death year, right? Birth year, death year. So to print this out, right, I'm going to do something like for, and that's where you begin to use other parts of what we've done in the class already. So you're saying for the index and key pair in information dot enumerate, print this, right? You're just using, this is just like a for statement, right? For the index and the key pair in this, do this. Let me just go through here. This is an example where it was actually run. So think of this, var class grade, assuming these are different class grades. So Steph has her class grade, Sarah has hers, Ken has his, Ali has his. So the first one where we included class grades, right? We didn't include the names of the people. So you have all those grades, but you don't know who has those grades. And then we're like, okay, we're no longer using arrays. Let's use a dictionary because I want to be able to match each individual to their class. So I can't use an array for that. Let me use a dictionary. So, but what if I want to run through each of them and print them out, right? It's going to be something like this. So for index, comma, key value. So in class grade, the important thing is that I'm picking my class grade dot enumerated, open and close bracket, and I say print, first of all, the index, because what I did here was that I called the index, right? This is 1, 0, 1, 2, 0, 1, 2, 3, right? But notice what's happening here. Like this was supposed to be my 0. Because it's an unordered pair, it just threw them out whichever way it liked. But the important thing is, I'm just saying, all I did was that I called for the index and the key value pair. In other words, I'm calling for the key value pair. So the index, and you can call this anything you like, right? But in the original format, right, we just know that whatever the first thing, let's assume this is X and Y, the Y is always going to pick the key value pair. Let me see, seems like someone is typing something. If you want to show the names of the students in the class, do you have to signify other classes first? If you want to show the names of the students in a class, you have to signify other classes first. I actually don't understand the question. Is there a way you can rephrase the question, Zane? try to rephrase the question. Let me see if I can understand. Like, signify other classes first. Well, the only thing I'm sure of right now is, so for example, if it's a particular class, let's say it's grade 10, I can just come here and say var grade 10, right? So you can call it whatever you want. I don't know if that's the question you were asking, but you can pretty much give these things whatever names you want them to. Because, so for example, the for this in this is a syntax, right? So even if I decide to call this any, so notice, let me go back. So here, see what I called it, key value pair, right? The only thing is there's a specific order where you want to keep these things. So I'm saying for this, I'm trying to run all of these in this, right? And I click enumerated. Once I say enumerated, the computer, because this is a specific function or a line of a body of code that has been written to say anytime you call this function, right, I need you to go through each of the elements and return them. That's what's happening. So I'm returning the index and I'm returning the key value pair, and you separate them with a colon, and that's what's happened here. So if I run this again, Sarah might be first, but it's always going to give me my index, right, and my key value pair. Okay, so these are other methods that you can also go play around with, right? So for example, if I have, I don't know, so this shows a method that is max or min. It probably might be particularly unique to, say, integers or something, or numbers, whatever, I don't know, but you have to go check this out. Or maybe I'm looking for, in a particular dictionary, I'm trying to find out if it contains something, and then you have to probably give what you're checking to see if it contains. So they will literally come here and say class grade dot uh, contains, and then you list what it is that you're checking whether it contains. Again, assume that this particular dictionary has 1,000 or 10,000 different entries. There's no way you can, by just looking at this, you can always find what you're looking, assuming it has 10,000 entries and you're looking for specific things. Maybe that's where it becomes important to use contains. Now, don't take my word for it because I haven't even checked out what contains does. But again, that's the whole idea of methods, to be able to build in some kind of intelligence on the part of the data type so that it can do specific things. So it's like superpowers that you're giving to these things to be able to do things, and they are all code that has been written to save you from going to write any code yourself. So the last collection type that we're going to talk about is the tuples, which is what I said. It's a compound collection type. It's not like your typical one of the three main collection types. And what are tuples, right? Like I mentioned, tuples are not one of the three main collection types, which like includes the arrays, sets, and dictionaries. So they are a completely different type of, so in Swift, a tuple is a group of different values. So it's your way of grouping different types of values. Each value inside a tuple can be of a different data type. So it can be a character, again, think of it like your U-Haul. The back of your U-Haul, right, is a container, is a big box of its own. But I can now store different data types there, right? After I have packed them in small boxes. That's like what tuples are. So they are generally used to group together multiple values of different types into a single compound value. U-Haul, literally. Yeah, the grade and class of different students before show the grade and class of different variable is grade. Just a minute, please. Is grade 10. How would you show the names of the different teachers? Would it be grade, teacher? Um, Not exactly sure of that. Um, Not exactly sure of what you are asking. That's something I have to look at again because normally the syntax, right? The syntax is kind of different than that. And I'm looking at so what you're talking about has to be done most likely. Oh, so I'm responding to a question on I'm responding to a question in the chat. So and Zen is asking, right? Okay, let me go back. So you know how you have your key um, equals to K and value is 56. Now, if you're trying to assign a key to multiple things, right, where you're going down, so for example, in a class, right, you have a class, you have a teacher, and then the teacher, right, has a number of students, and each of the students has their grades and all of that. Like, how do you organize it? I don't think that's something dictionaries can do because if you look at their syntax, it's usually literally um, like your dictionary. So it's at, and the question you raise is a very important one because it helps you begin to understand the challenges in organizing your data, right? So for most people that study computer science, one of those required classes is actually data structures and algorithms because that's where you begin to see different types of structures and now more like user defined structures that you can create to be able to solve different kinds of programs, different kinds of problems. So for example, dictionary doesn't look to me like what you can use to solve this problem, but there are also other ways in which this can be solved. Hopefully, we can talk about those one of these days too. Yeah. So um Tuples. This is more like where you can begin to do some of what we are even tuple is more likely to be able to help us do the kind of things you're mentioning. And beside tuple, we also have other data types. So this is an example. Unlike some of the other data types that we've talked about, particularly array and set, now you can put different kinds of data types here. So this is literally a string. This right here is an integer. This is a double, right? And then this is another string, but you can pack all of these things together. So for example, name, John, age, 25, job, developer. So look at, if I've written this line of code, right? And that's a tuple. Look at what I'm doing here, right? So I can do this. This is slightly different from what Zane is talking about, right? But it's close to it because I want to be able to, for example, if this is a class, I can include this, and then for the values, I will tell you who the teacher is, right? And then all the students can have their own values. Then it can meet the particular thing. I don't know whether that will be the most efficient way to do it, but then it just brings us very close to, because I list first of all the teacher assistant, and then I give a value to every other student, right? And then somehow I can actually, because a tuple can actually take a dictionary and an array. It can take a dictionary and a set. So you just have to be able to now design the way everything is organized. But you can't do that except you understand these various data types and you know how to, what they do, so that you can now begin to combine them. So tuples are really, really very interesting things to do. So that's me. I'm talking about a particular employee, right? And look at all I have done. So for this The tuple name here, sorry, this is actually a mistake. This is supposed to be let employee equals to name. So let me, just a minute. Let me actually correct it on the fly, because sometimes I'm like, I'll correct it later, and I don't, and I just send it to you in the same way. Yeah, so it's supposed to be something like this. So let me just give this guy some color so that we can know. So save. Okay, it's okay. Stop saving. So let employee, then we have the name, we have the age, and then we have the job title, or the title or the job. So to be consistent, let me just say title here. Since I use title below, and I'll show us where I use title and why. So let's say, and I want to make these things very unique so that you can actually see what the differences are. So that's what we have here. So essentially we've created this tuple, and notice the tuple is the brackets, right, are rounded, as against the other ones that are squared, right? So I have this, I have name, I've inserted his age, I've inserted his title. So if I break this down, right, I do like an analysis. The name of the tuple is employee. The employee's name is the first thing, which is John. Employee's age, 25. Employee's salary, um, where did I include? Okay, that's the salary. And I did not include that here for salary. Okay, I included salary here. So let me do the salary thing too. Sorry about this salary. Salary, and then 100,000. And I deliberately use the .00 so that I can make a distinction, so it's a double. So I'm gonna say something like this, and this guy is 42. So this is gonna be white, so that we are consistent, and this is gonna be white too, so we are consistent. So I guess you see what I'm doing here, right? Yep. So that's what we have here. So essentially, the tuple name is employee. Now the actual name of that employee will be John. Their age 42, their salary 100,000, their title they're a developer, right? So that's one way to represent this. So you can either represent it this way, or you can represent it this way. That's the alternate, which is what I did here. That's the alternate. Sorry. That's the alternate. This is the same thing as this. I think I was trying to get rid of this. So this is the same thing as this, right? You either do it this way, your system will recognize it, or you do it this way, which is literally all you have done here is you have actually created dictionaries inside a tuple. But why is this different than a dictionary? You have your round braces, and I can say comma, and I'll just include some other thing that is not a dictionary. It can be a set. I can actually call a set from inside a tuple. I can call an existing array from inside, and it's good. So it's just think of it like your U-Haul, the back of your U-Haul. You can throw in everything you want there, and it will be able to manage all of it, provided you have boxed everything. So which brings me back. I don't know if there are any questions. If anyone has questions, or else, or maybe let me see. Let me see if there are any questions. around name or not. Let me see. Boom, 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 boom. Okay, for name, no, no, wait. What did I do here? Okay, let me interrogate that. But I think let's have let me see, about 10 minutes break. We come back and then I'll run through the second part of uh, of the slides. I'm going to save this and stop recording too. So finish with this data type. When we get back, we're actually now going to go look at things like classes, structs, and all of that, and begin to interrogate deeper concepts like properties and methods, and walk us through a couple of other things. All right. Thank you. Laura, I'll get back to you when we get back. Thank you. 10 minutes. So let's come back by 7:37. Thank you.